Okay, so this is an example. It's an example from the textbook. So it's about superposition. It says now the question says use superposition theorem to find V. So we want this V and we want to use superposition theorem. What we can do here is just one of the example quickly. We can actually close one thing and then we open another one. So a quick explanation is that in superposition we remove this source, we will remove one source and then calculate the voltage via the other source, and then we're gonna again calculate the voltage via this source and then remove that source. That means we calculate with the independent sources. So what we're gonna do now is that I'll start by using 6 volts, and then if I'm using 6 volts now, it's gonna be plus minus, and then I'm gonna have a resistor here, and then what I'm gonna have here, I'm gonna have a 4 ohms resistor, this resistor, and then 4 ohms resistor, and I have something like this, I have something like this. So now what's gonna happen here is that in superposition theorem, for current source, current source, we actually open circuit, and then for voltage source, for voltage source, we actually close circuit. So what's gonna happen now here is that we're gonna have 4 ohms here, and then we're gonna have 8 ohms here, and then we're gonna have 6 volts, and then we just removed. If you check, there was a current source here. When you go back in this current, instead of this current source, we removed it and we replaced it with an open circuit. So now what we're going to do is that now we're going to calculate, since they want the voltage, we can actually use voltage division, because we have 6V here. That means we can use voltage division to find the voltage that is at 4 ohms. So, or else if we do not want to use voltage division, we can actually calculate the current. So if I'm using the current, now what I'm gonna do is that I'm gonna find R equivalent, which is gonna be, these resistors are now in series, since that line there is removed, so it doesn't have any effect. So that means 8 and 4, they are in series. So what's gonna happen now is that I'm gonna have 8 plus 4, and then this is gonna give me 12 ohms. And then what I'm gonna do now is that I'm gonna say I total is actually V over R, and then I have my 6 volts, which is the total voltage there, and then divide by R, which is 12 ohms, and then 6 over 12 is about 1 over 2, which is 0.5 amps. So that's the total current that I get. So after this, now that means now I can find, because now this, since 8 ohms and 4 ohms, they're in series, that means the current that is at 8 ohms will be the same as the current that is going to be at 4 ohms, and then that current is what is 0.5 amps. Then now I'm going to calculate the voltage and say voltage is equal to IR according to Ohm's law, and I have this 0.5 amps, and then I'll multiply by the resistor, which is 4, and I'm gonna get let me try what I get there. It should be about 2, because 0.5 times 4, yes, that's gonna be 2 volts. So that's the voltage I get there at 4 ohms resistor, due to what? To the 6 volts source. Now what's gonna happen now? I'm gonna call this V a V prime, because now we're still gonna calculate another voltage using now the other source. So what I'm gonna say now, I'm gonna add another slide. Now I'm gonna take this circuit, I'm gonna redraw that circuit now. But what I'm gonna do now, remember, I'm gonna remove a voltage source. But when I'm removing a voltage source, what's gonna happen is that I'm gonna actually have something like this, and then I'm having my current source there, and then this is what I have. I'm gonna have 3 amps here, and then I'm gonna have 8 ohms here, and then I can have 4 ohms here. So what's happening now, you can see that now when we are removing the voltage source, we are replacing it with a closed circuit, but when we removed the current source, we replace it with what? With an open circuit. So what's gonna happen now is that from this stage we can again or in fact these, they are already in parallel, because you see they are sharing this node and that node, so they're actually sharing two common nodes. So that means the resistors are in parallel, the 8 and the 4 ohms. So what's gonna happen now is that, and I'm given the direction of the current now is going upwards like that. So what's gonna happen now is that I can actually use current division to find the current that flows at 4 ohms, because remember the voltage that we are concerned with, it was the one that was at 4 ohms. So what we're gonna do now, we're gonna use current division and can say the current that is flowing at 4 ohms is gonna actually be 8 divided by 8 plus 4. It's just that one divided by the total and then multiply by 3. And then now let's see which is the total current. I'm gonna have 8 over 8 plus 4, and then I multiply that by 3, and then I get 2 amps. So I get 2 amps. So now what I can do now is that I can say now V is actually IR, and then I know my I that I'm having 2, and then I know my resistor there, that is 4, and I'm gonna get about 8 volts there, 8 volts there. Yes, so we wanted actually the voltage. So I said this one, remember at first is V prime, I can say this one is V prime prime, but for the sake of direction, we can say the direction here, let me change and try to use another thing. So we can say the plus sign of the source of the voltage source here in this case is coming this side. That's the direction of the current coming this side and then coming downwards here. So that means the direction was downwards towards that 4. And then for the second one, using this source, is coming upwards there like that in that direction, as we are given the arrow there is represented by the arrow of the current source, and then when it comes here, it's gonna come downwards. So since the direction are down, that means I'm gonna have 83. So even the I here, I can say I prime, and then for this one I can say I prime prime. So to find the total current now, the actual current that we need to add the current I prime, which we found due to the 6 volt source, and then we add plus to the current I prime prime, which we found due to what? To the 3 amps source. So now it's addition because of that direction, they are both directed downwards. So that means I can say now the first I, which is gonna be, I got 0.5, and then I can add to the second I there, which is about 2 amps, and then I'm gonna get 2.5 amps. And then I can say V is equal to IR, and then I know now that my current is 2.5 multiplied by the R, which is 4, and then I'm going to say 2.5 times 4, I get 10 volts. So this is actually the voltage that they wanted there. So you can actually see that even from the voltages, if you started by doing the voltages instead of adding the current and using Ohm's law again, you could actually take these 2 volts and then you add to this 8 volts, since they're in the same direction, and you will get the same 10 volts. So that's it.